Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about isometric projections. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now today we are going to discuss about the procedure that how do we evaluate the isometric projections of a solid when the orthographic projections of the component or the solid they are available with us. Now here we have the orthographic projections in which this is the front view of the component. Here we have the top view drawn over here, and we have also been provided with the right side view. So the right side view in the first angle projections, it will be drawn on the left hand side. Now first of all, we need to develop three surfaces while we have to draw these projections over there. What are those three surfaces? We need to work out the dimensions of the front face, we need to work out the dimensions of the side face, and we need to evaluate the dimensions of the top face of this particular solid, so that once we have the idea about the dimensions of all the three faces, because in the isometric projections all the three faces of the solids they have to be drawn into a single figure over there which will be represented onto the same plane. So all the three faces they will be available in the isometric projections in the same plane. So here in the orthographic, where we had got three separate views for the front view, top view and side view, in this view, that is in the isometric projections, we are going to get all these three faces drawn into a single plane. So first of all, we will be evaluating the dimensions and the sizes of the three faces so that we can obtain a rectangular prism or a square prism corresponding to the solid for which the isometric projections have to be developed over there. So let us work out the front view. Please check, this is my front view. Now using the front view, I can evaluate that the length of the solid, it happens to be 70 millimeter, and from the side view I am going to get the dimension of the height. So the height is available to me as 60 millimeter. So in the front view, so this rectangular face which will be drawn in the isometric projections corresponding to the front face, it will have the dimension 70 millimeter will be the length and 60 millimeter will be the height over there. So the front face dimensions will be 70 millimeter by 60 millimeter. Now let us work out the dimensions of the top face. So the top face, once again, the length will be equal to 70 millimeter, and regarding this width, so this width is available to us from the side view. So this is available to us as 60 millimeter. So this distance we can mark as 60 millimeter. So the top face dimensions will be 70 millimeter length and the width will be equal to 60 millimeter. So the top face dimensions we have marked as 70 by 60. Then the side face. So the side face dimensions they have been provided to us as width is equal to 60 millimeter and the height it is equal to 60 millimeter. So this becomes a square face over here, right? So here we get the side view will be represented within this square face over there, whereas the front view and the top view they will be represented with the help of rectangular faces. Now we need to show that in which planes we are going to mark the front view and the side view. So we can see that here we have obtained the right side view of this particular solid which has been drawn on the left hand side. So since we have been provided with the right side view, so the side view face, this face, so this face should be available along the z-axis, and once we are drawing the plane, that is the square face over here which will be 60 by 60 on this right hand side, only then the right side view projections they will be obtained onto the orthographic projections, and these have been drawn on the left side. So this edge will be drawn as 60 millimeter. So please check, this edge should be drawn as 60 millimeter, which will correspond to the width of the solid, and the y-axis. So this is my y-axis. So y-axis height should be drawn as 60 millimeter, so that once I complete these two isometric edges over here, so a square face corresponding to the right hand side view will be drawn. Similarly, the front face. So if this is my side view, so this will be my front view. Now I know that corresponding to the front view, the length has been provided to me as 70 millimeter. So I am going to draw the front view length equal to 70, and now obviously the height will be 60 millimeter, which is same as the side view height, right? So this will be 60. So this 70 by 60 rectangle, so this is going to give me the face corresponding to the front view. Now for the corresponding to the top view, now I can draw another isometric edge 60 millimeter parallel to the z-axis, and another isometric edge I can draw from this point, which will be 70 millimeter length, and this will be parallel to the x-axis. So 70 by 60. So this will be giving me my top face, or this will be giving me my bottom face over there. So in this case, the construction of the isometric projections we can proceed with only when we have completed with the construction of this cuboid. So into this cuboid, or we can say this becomes a square prism. Why this is a square prism? Because the height and width of the solid is equal to 60 millimeter. So this shape will be shape of a square, right? So this is a square, and since this length happens to be 70 millimeter, so this becomes a square prism having a length of 70 millimeter. So once we draw this particular cuboid, then we know that front view dimensions, they will be shown along this particular length. Then the width dimensions, they will be shown along the z-axis over here, and the dimensions related to the height, they will be shown along the y-axis. Now in order to draw the projections of this particular solid, what we need to do, first of all, whatever dimensions they are available corresponding to any one of these three views, that is front, top and side views, we have to draw all those dimensions along the true length, and we need to convert all those dimensions into their isometric lengths. And once we are able to convert all these dimensions into the isometric lengths, then we can proceed with construction and projection of all those edges into the isometric projection view. And then the second thing we need to do, because if we straight away look at this object, it may seem to be little bit complicated. No, it is not complicated. This thing we must understand. Only thing is, we need to pay attention to the different elements of this particular solid. And once we break down this entire solid into small elements, then the proper understanding of every element will be very easy, and then we can have the breakdown of these elements first of all. And once the breakdown into elements has been done, then we will be able to draw the projections corresponding to each one of the elements onto the isometric projections quite easily. But first of all, we are going to start with construction of a square prism, which will be representing the three faces of the solid over there. Then we will see how we are going to break down each element of this particular solid, so that we can have the convenience of plotting all these elements onto the isometric projection plane over there. So step number one, we draw the isometric scale so that the conversion of all the dimensions into the isometric lengths is possible. Then we start with the construction of the horizontal datum line, right? So this is our horizontal datum line. Now with respect to the horizontal datum line, we have a starting point, origin over here. From the origin, we have drawn the x isometric axis. This is the isometric x axis, which has been drawn towards left at an angle of 30 degree. So this isometric x axis has been drawn towards left side at an angle of 30 degrees. Similarly, the z axis, it has been plotted towards the right hand side and again it has been inclined at an angle of 30 degree with respect to the horizontal datum line. Now next we know that the length of this solid happens to be 70 millimeter. Now we have marked this length along the x-axis because we know that along this face I have to show the front face of this particular solid, and the front face is going to measure length is equal to 70 millimeter, height should be equal to 60 millimeter. So length I have been able to mark over here, height also I have shown. Now let me draw the projections of these two edges corresponding to the length of the front face and the height of the front face. So the length we have marked it equal to 70 millimeter, and the height of the front face we have marked equal to 60 millimeter. So this length is 70 and this length is equal to 60 millimeter. Then we will be drawing two isometric lines over here. This will be parallel to the y-axis, again equal to 60 millimeter. This isometric edge corresponding to the front face of the rectangle we have drawn parallel to the x-axis, and this also measures distance is equal to 70 millimeter. So this is the construction of the front face of this particular solid into the isometric projections. And once we have drawn this front face, now we will proceed with construction of the side face. So we know that the dimensions of the side face, they are 60 millimeter by 60 millimeter. So in the side face you have the height is equal to 60. So this has already been plotted. So this height already comes from the front view. So the height in the front view is same as height in the side view. So this has already been plotted. Now we have plotted now the width of the solid. Please check. This is going to be the width of the solid, and this width of the solid we have marked as 60 millimeter. And then we need to draw two more isometric edges corresponding to the side face square surface over here. So this is a square surface. So two more, you see, isometric edges we need to plot over here. So this is one isometric edge which will be parallel to the z-axis. This is another isometric edge which will be parallel to the y-axis, and all the four edges of the square they will be measuring 60 millimeter. So height is 60 and the width is also 60, and this is a square face, right? Then we work out the construction of the top face. So we know that in the top face what are the dimensions which will be required? 70 millimeter is the length. So we have already drawn this as 70 millimeter while we were drawing the front view. So this 70 millimeter has already been drawn. Similarly, this width. So width has already been drawn as 60 millimeter through the right side view. So now these two edges, they are already available with us for the top view face over there. Now another two isometric edges, they have been drawn corresponding to the top face, which is a rectangular face of this particular solid. So here this edge will be drawn parallel to the z-axis. This edge will be drawn parallel to the x-axis. So this edge measures 70 millimeter. This is also measuring 70. This is also measuring 70. Similarly, this edge will be measuring 60 millimeter. This is also 60 and this is also 60. So the top face has been plotted. Now let us start with the construction of the bottom face of this particular solid. Now in order to draw the bottom face, we have to draw one isometric edge corresponding to the bottom face of the rectangle, which will be parallel to the z-axis. So this is z-axis and the length of this edge is 60 millimeter. So this edge length will also be drawn equal to 60 millimeter. And similarly, another edge we are going to draw corresponding to this rectangular face at the bottom. This will be parallel to the x-axis, and the edge length will be, it will happen to be 70 millimeter. So now the top face has been obtained, the bottom face has been obtained. Now we are going to join this corner with this corner, so this is the vertical height which is appearing on the rear side of this particular square prism. Now we have developed a square prism in which onto this surface the front view elements will be drawn or projected onto this face. The side view elements, they will be projected, and onto the top face, this is our top face, onto the top face the elements corresponding to the changes in the cross sections of the solid, they will be plotted along the top face surface over there. Now we have to evaluate that how do we plot all these dimensions over here, because if we look at the solid in totality, it might seem to be complicated, but if you have the proper understanding of this particular procedure, you will be able to transfer all these dimensions into the isometric projections very easily. So let us try to divide this solid into multiple elements, and let me tell you, we can divide this total solid only into 3 elements. If you are able to understand these 3 elements appropriately, then construction of isometric projections, it is going to be very easy. So element number 1, so as usual you can see this is my total solid. If I look at it from front, so these are the 3 segments which I am able to see. This is one segment, second segment, and third segment. Now first of all, I am going to, because build the solid from the bottom, so this is the first element I am going to focus upon. So please check, here I am going to get a solid line corresponding to this front edge over here. So this means that this particular edge, it is running through and through the entire width of this particular solid, right? So this is the entire width over there. And another thing, by combining this front view with the top view, I have understood that this is particularly one element which is having length, please check, length is equal to 70 millimeter, height of this first element, it happens to be 20 millimeter, right? And then another thing, if I combine this shape with the top view, I will find that this element corresponds to this big shape in the top view, right? So this is the bigger shape to which I have got 70 millimeter length and 20 millimeter block height. So if I consider this element as a one block, so this block will representing this much portion of my top view. That is why I am getting a horizontal line over here, because these two surfaces, they are lying on the back side of the solid, on this side and on this side. So this is one block which I have to draw first of all. Okay, so this is one element. So I have been able to decode the details of element number 1. So element number 1 means there is a block which is having height of 20 millimeter, length is equal to 70 millimeter, and bulk of this surface, it is going to be corresponding to element number 1. So this is the top surface which will be having the height is equal to 20 millimeter. Now let us decode the second element and the third element. So the first element has been decoded. Now let us decode the second element. In the second element, please check, I have been shown a square block over there. You see, this is a square block. So these orange dimensions, these I have added on to my drawing. Just we want to simplify this construction. Otherwise, this 30 millimeter width is already available over here. So here in the orthographic projections, few dimensions they are shown in the front view, few dimensions they have been shown in the top view. So I have combined this length dimension from the front view with the width dimension of the top view. So once I want to decode this element, so I need to work out both of these dimensions of this particular second element. So in the top view, you see, I am able to get this length of this element which is given in the front view equal to 30 millimeter, and the width of this element is given to me as how much? 30. So 30 by 30 square element is there. Where does it lie? It lies in the rear end. Please check. It lies in the rear end of the solid. So in the rear end, a 30 by 30 block is there. And how much is the depth of this block? Please check. Total height of this block happens to be 60 millimeter, out of which the height of the first block, this is equal to 20. So if the height of the first block is 20, so the remaining portion of the height will be 40 millimeter. It means that the second element, as it has been decoded, there is a square block 30 by 30 lying on the rear corner over here, and it will be moving down. That is, the height of this square block should be 40 millimeter. So this is the second element which has been decoded. Let us decode the third element over here. So this is the third element which is having length is equal to 40 millimeter. Please check the length as it is appearing in the front view, it is 40. How much is the height of this element? This is equal to 20 millimeter. So height of this element is 20 and the width is how much? Width is equal to 20 millimeter. So again, this is a square prism basically. I can treat it to be a square prism having, please check, this is my height, this is my width. So height and width, they are equal to 20. So on this side, I will be able to get a square of 20 by 20, and this length of this block, length of the square prism which I am going to draw over here, so this will be 40 millimeter. So all the three elements, once they have been decoded, so we can start with the construction of the isometric projection. So we know that bulk of the portion of this particular solid corresponds to the element number 1, right? So this is my element number 1. So in the element number 1, what is happening? Length is equal to 70 millimeter. Height of the first block, which is the block at the bottom, right? So this block at the bottom, because you can see this is the first block and it is running even up to this point over here. So it is running up to this point, right? So it means that this block of 30 by 30, it has been placed over this particular block only. So majority of the portion of the solid is comprising of element number 1. So I can extend this length, right, as a construction line, so that I can draw this element which is having a height of 20 millimeter, and then I am going to draw a ring over here. So I will be drawing a ring which will be having height from the base equal to 20 millimeter. So once I draw this ring, so ring will be passing through all the edges over there. So because this is the major construction, so please check, majority of the element number 1 has been constructed. Once I draw this height of this ring, so this becomes a ring over here. This is my block which is lying at the bottom, having height is equal to 20 millimeter. Length, please check, the length of the block happens to be 70. So this is perfectly drawn. Height, it is 20. Now certain portion will be covered by the square block and this again a square prism over there, right? So this is a square vertical prism, this is again a square prism. Please check, this is 30 by 30 prism which is standing upright on its axis having a height of 40 millimeter, whereas this is again a square prism where the square face is appearing over here and the length of the prism is like this. So we can say that this is a square prism which is resting on one of its rectangular faces. Where it is resting? It is resting on the bottom block. So this is my bottom block. You can see element number 1 has been drawn over here, right? So once we break this into multiple elements, construction becomes very, very easy. So the first block has been drawn. Now we need to evaluate which portion on the top surface of this block has been covered by this prism and this prism over here. Let us start with the element number 2 now. I know the dimensions of element number 2. Where does it end? Element number 2 ends at the top surface. That is, it is having the dimensions 30 by 30 and it is going up to the height of 60 millimeter. So I will be drawing 30 by 30 square block over here. So this is my 30 by 30 square block. So here I am getting, this is the length of the block 30 millimeter, this is the width of the block. So we can check, if I look at it from top side, this width will be, this square will be available on this corner. Please check, the square will be available on this corner. So this square I have obtained, that is 30 millimeter is the length, 30 millimeter is the width over there. Please check, 30 millimeter is the length and 30 millimeter is the width. So I have drawn this square block on the top. Now I need to draw this height of the block. I know the height of the block, total length, you see, total height of this block is equal to how much? 60 millimeter, out of which 20 millimeter has been covered by the bottom block, that is element number 1. So the remaining height of this block will be 40 millimeter. So this is again a square prism. Square I have been able to draw. Corresponding to the square prism, now the vertical edges I need to draw. Vertical edge number 1, vertical edge number 2, vertical edge number 3. Right? So this is a square prism having the bottom and the top equal to 30 by 30. So which has been drawn. Now I am going to draw the y-axis. Please check. This is the y-axis. Right? So this y-axis I will be drawing, and this y-axis length is how much? I need not measure even this, because this 20 millimeter I have already drawn. So the remaining portion of this total 60 will be 40 millimeter only. Right? So please see, total was 60. 20 I have already taken out for the ground element or the bottom element number 1. So once I draw the vertical projector line, that is, this is the longer edge of the square prism. So this is longer edge of the square prism. This is second longer edge of the square prism. This is third longer edge of the square prism. And every longer edge, it is going to end up at the ring only. So since these were the corner points, so even this point will be ending up over here. So since this is the interior point, it will be lying on the surface of this top of the element of this ring that we had drawn corresponding to the block number 1 or element number 1. Now we have drawn the top face of the square block. I will be joining the bottom face of this square block over there. So height I have shown just for convenience. Even if I am not marking this, it would be alright, or it would be perfectly appropriate, because this total is 60. 20 I have already taken out through this ring. So automatically the remaining portion is 40. But still, for the clarity, I have drawn this dimension equal to 40 millimeter. Now I have to complete the bottom. So please check, this is the base of this square prism, which is resting on its base, square base 30 by 30 onto this element number 1, onto the top side of this element number 1, and the height of this prism happens to be 40 millimeter. So element number 1 has been drawn, element number 2 has been drawn without any difficulty. Now element number 3 I need to work out. So please check, in the element number 3, this is the length of the element. How much? Please check, total was 70. Total was 70. I have already taken out corresponding to the square 30 millimeter side. So the out of 70 millimeter length, 30 millimeter is consumed by, it is being used by the square element which was resting upright. Now this is again a square prism which is not resting upright. It is resting along its rectangular base onto the top surface of this element number 1. Now here 20 by 20 will be my square face which I should be obtaining over here. 20 by 20 will be my square face, and then this length I will be using as 40 millimeter. So this is the breakup of the element number 3. So in order to draw this 20 by 20, please see, this is my 20 millimeter. This is also height is 20 millimeter. And I can say that if this is 20, this is also 20. So the top edge or the top face of this particular second block, it will be lying 40 millimeter from the ground. Right? This will be lying 40 millimeter from the ground. So that is why once I draw this edge, which is corresponding to the top face in the front view, corresponding to the element number 3, right? So this height of the top face of the element number 3 will be 20 plus 20. So this is equal to 40 millimeter. So please check, I have marked this equal to 40 millimeter. And then again, for your description or ease, I have shown 20 millimeter above this ring. So this was the ring which was there on the top first surface of the element number 1. So you can show either this 40 or you can show even this 20. So one of these two dimensions you may not show, but just to have better clarity and better visualization,
I have shown dimensions on either side. Okay, now this was equal to 40 millimeter. So this height I have taken as 20, and now the width, you see, height I have drawn as 20. This height is 20, this height is 20. Now I need to show this width of 20. Please check, I need to show this width. Height I have already shown. You see, the height of element 1 was 20, height of element 3 is 20. Element 1 height is 20, element 3 height is again 20. Now I need to show the width. So the width is again 20. So this 20 mm is the width which I will be marking over here. So this is the width of this square prism which is resting on its rectangular face onto this top face of element number 1. So please check, this 20 by 20 I have drawn. Now I can complete this portion. This is 20, this is the top face. Please see, this top face is having the width 20, it is having the height 20 from the top face of the element number 1. Now I can drop this height over there. Please check, I can drop this height here perpendicular to this surface. Over here also perpendicular I can drop. And why I am dropping perpendicular? Because these are all representing y-axis, and y-axis is always perpendicular. All the vertical dimensions, they have been drawn parallel to the y-axis. This is the beauty of this isometric projection. That is, we are going to use only the isometric lengths over there, right? So rectilinear distances, they have been measured to represent all these faces. Now we can visualize, this is a square block. Now this is the base over here. This is a square block. Please check, this is a square block, and this is a which is resting on its base over there, and this is a rectangular face. You can check, this is a rectangular face onto which the element number 3 happens to be resting on the top surface of the element number 1. So with this we have completed the construction of all the 3 elements. This is element 1, this is element 2, this is element 3. So let us now once again correlate between these figures. In this figure, length is 40, height is 20, width is 20. Please check element number 3. Length is 40, width is 20. So width is coming from here. Height is 20. Height is coming from here. So element number 3 is decoded. Element number 2, this is 30. That is, length is 30. Please check, length is 30, width is 30. So width is also 30, and the height is 40. So height is 40. So element number 2 is completely drawn. Element number 1 we have already discussed. The height is equal to 20 millimeter, length is equal to 70, length is 70, height is 20, and it will be covering this much portion of your solid. Now let us start joining the edges dark. So whatever edges they are visible, they are going to be drawn dark. Please check, top surface has been drawn dark, square. So square is visible? Yes, it is visible. Square is visible? Answer is yes. This is also dark, this is also dark. So square has been drawn dark. Now vertical edge. So vertical edge of the square, they are visible. Please check, this is also visible, this is also visible. So drawn dark. Then this is my square prism resting horizontally. This was the square prism which was standing vertically over there. That is, square was 30 by 30, height was 40. So this was vertical square prism. This is horizontal square prism resting on its base. Now let us complete this portion. This is resting on the top surface. Now work out element number 3. This is the top face of this element. Please check, is it dark? Yes. Answer is it is dark. Please check. From the top we are able to see this, it is dark. Then from the front, I know the height. So this is also dark, this is also dark. Now why we have not joined this? Because look at the side view. If you look at the side view, in the side view, this is the L-shaped projection. Please check, this is L-shaped projection, and then we are getting L-shaped projection over here, and then this is, there is continuity in the surface over here. So there is no line. So since there is no line, there is continuity. So this is my side view. So side view elements, they will be located on the right hand side face. So I did not join this dark because now I am going to join this dark, because again corresponding to the second block, there is continuity in the surface over there. So please check, another L has been obtained, L-shaped surface from the side view. So this side view is completed now. Please check. So it means there are no elements over here. Now I can complete this phase, and once I complete this way, so I am able to get all the construction of all the three elements. Element number 1, it is this one over here. Element number 2, it is a square block having a height of 40 millimeter. It is resting on this corner, you see, with this aligned with this corner at the back, aligned with this corner at the back, square 30 by 30 at the top, and height is equal to 40. So square 30 by 30 at the top, height is equal to 40. Then this is again another square block which is resting on top of this element number 1. So this is having length 40, height 20 and width 20. So length 40, height 20, and it is having the width 20. So all these elements, they have been appropriately constructed, completing the entire shape of the solid. So this is the discussion about construction of the isometric projections of the solid when the orthographic views they have been provided to us. So I hope that through this construction you would have understood the procedure to develop the isometric projections using the information given in the different views of the orthographic projection. So we have divided the solid into multiple elements, and then working out the details of the multiple elements, we have been able to complete the construction of the isometric projections. So this is all for today. So thank you very much. Thanks a lot.